Relationships between two categorical variables R tutorial. In our last R tutorial, we saw a graphical measure for describing the relationship between a quantitative and categorical variable. Today, Allison discussed the relationships that can occur between two categorical variables. In this R tutorial, we will learn how to obtain the distribution of one categorical variable, the joint and conditional distributions for two categorical variables, and we will learn how to plot side-by-side or stacked bar plots. Let's remind ourselves about the skeletal remains dataset. Our focus today will be on the two categorical variables, sex of the skeleton and its BMI or mass category. A quick house cleaning issue we should address before starting. When a categorical variable is read into R, by default the categories are recorded in alphabetical order. This means that any table or graph we produce for the BMI variable will have the categories in the following order: normal, obese, overweight, underweight. Of course, we know that there is a much more logical order to the categories, that is, underweight, normal, overweight, and obese. We can change the order of the levels in R with the factor command, specifying explicitly what order the levels should be in. We can similarly relabel the sex variable, indicating the levels, 1 or 2, and the labels, male or female. Let's first obtain the distribution of the BMI categorical variable with the command table. Recall that the relative frequencies can be obtained by dividing each entry in the table by the total sample size, 400. We can combine the frequencies and relative frequencies for better viewing. Similarly, we will do this for the sex categorical variable to obtain its distribution. For the next few examples, we will need to install a new package called Gmodels. Packages in R are like tool belts. They each contain specific tools that we can use depending on our needs. We will navigate to Packages and Data, Package Installer, and click on Get List. Now we can search for Gmodels. Select the package, select Install Dependencies, and finally Install. You will notice the process of the installation in the R console, and once it has finished installing, you will see the prompt again. We will need to load this new package by saying Library Gmodels, so that we may use some of the commands contained in the package. We now have access to a new command called crosstable. This command generates the joint distribution and conditional distributions for two categorical variables. Let's create these for the BMI and sex variables, choosing to suppress some of the output with the argument prop.chi² is equal to false. First, we'll note that there is a legend specifying the contents of each cell. For example, if we extracted the first entry in each cell, we would get the joint distribution, or the contingency table, of sex and BMI. An easier way to see each of the nested tables is by typing in joint, the saved cross table. Here we can see the first table is the contingency table. The second table is the conditional distribution of sex given BMI. The third table is the conditional distribution of BMI given sex. And the last table is the contingency table displaying relative frequencies. We will save the contingency table with the counts to be able to construct the side-by-side bar plots. With the bar plot command, we will specify the counts that need to be graphed. We will specify that we wish the bars to be beside each other with the beside is equal to true argument. We will set the colors and labels for the X and Y axes. It's useful to have a legend for these types of graphs so that we know which colors indicate which categories for the BMI variable. Let's build our legend with the legend command. The first argument specifies the position of the legend, here at the top right corner. The second argument specifies the names. Note the order is identical to the order we have set for the levels of BMI, starting with underweight. The third argument specifies the plotting symbol. In our case, 15 is a little square. The fourth specifies the colors. Here, note that you must use the same colors as you did in the bar plot command, otherwise the colors won't match. Try to play around with some of these different arguments to create a plot that looks visually appealing to you and is descriptive for your audience. For the stacked bar plot, we just need to change beside is equal to false, and we obtain the bar plots stacked on top rather than beside one another. Recall that from the cross table command, the prop.call nested subtable gave us the conditional distribution of BMI given sex. Using this table, we can create stacked bar plots, which will give us a visual representation of the proportion of each BMI category for males and separately for females. For the Patricia example, we don't have the actual data, but we do have the contingency table. That is the counts for the number of women measured on two variables, treatment group and infection status. Let's enter these manually into R using the matrix command. We will enter these row by row, starting with 23, 6,140, 345, 5,673. We will specify by row is equal to true, and that the number of columns is equal to 2. For completeness, we will set the names of the rows and columns appropriately. This will make our tables and graphs easier to read, since they will automatically be labeled. Recall with the cross table command, we can obtain the 4 tables that Allison discussed in the lecture. The frequencies, the joint distribution, the conditional distribution of infection status given treatment group, and the conditional distribution of treatment group given infection status. In Allison's last example, we have a 20-year follow-up study on survival rates between smoking and non-smoking women, and to obtain the data, we will need to install a new package called SM Practicals. Again, we will navigate to Packages and Data, Package Installer, and click on Get List. Now we can search for SM Practicals, select the package, select Install Dependencies, and finally install. We will load the package with Library SM Practicals. To see the dataset, simply type in smoking. Notice that the data is already aggregated by 3 categorical variables: age group, smoking status, where 1 indicates a smoker and 0 indicates non-smoker, and current status, alive or dead. Now all you need to do is pick out the numbers that you want, depending on the variables you're interested in looking at, and enter them into a matrix like we did in the Patricia example. See if you can recreate the bar plots that shed some light on the Simpson's paradox that's present in the dataset.